In order to understand the concept of reactor unit processes, let's define unit processes yet again. It is the basic steps in the chemical industry or operations involved in the transformation of raw materials into finished products or chemical products. And these processes involve both physical and or chemical changes. Then we can have this list here to see we have the fluid flow processes, which examples are in transportation, filtration, and fluidization. Then we have a heat transfer process. An example is evaporation and heat exchanges. Then we have the mass transfer processes like gas absorption, distillation, extraction. We have drying. So they are all mass transfer processes. We have thermodynamic processes such as gas liquefaction and refrigeration. And then we have the mechanical processes, which are solid transportation and crushing, milling, screening, and all of that are mechanical processes. So we also have chemical reaction processes such as polymerization, esterification, nitration, sulfonation, desulfurization. All these are chemical processes. Then we have the separation processes or operation such as the distillation, crystallization, filtration. These are separation processes. Then we have the mixing and blending processes. Okay. Then we have the reaction processes. We have the catalytic reactions, fermentation. So we have these as the examples of unit processes. Each unit process is designed to achieve a specific transformation or separation, and multiple unit processes are often combined to create a complete chemical process. All right, the design and operation of unit processes are critical to the efficient and safe production of chemical product. So the first stage being the fat and oil processing. Okay, that is the first stage in the manufacture of soap. And the fat and oil processing has to do with crushing and grinding, then extraction using solvent extraction, then refining. Refining in this sense means either degumming or neutralization. So we then have after the fat and oil processing, once it's ready, then we have the alkali processing, which entails dissolution, dissolving sodium hydroxide. Okay, and then we have which could also be separated by filtration. Then we have the saponification unit process. So the saponification process has to do with mixing and blending of the fat and oil with the alkali, and then heating it and agitating it for the reaction to occur for soap formation. Then the next stage could be neutralization, which entails addition of an acid, say citric acid, just to adjust the pH. Okay, so we could have the next unit process to be the bleaching and coloring. which has to do with addition of bleach. Bleach, hydrogen peroxide could be added, and colorants, such as dyes or pigment could be added. Then we now have the mixing and blending, which entails combining soap with other ingredients, okay, such as preservatives, such as fragrances. All right. Then we now have the shaping and forming. Here, the desired shape of the soap is created, all right, based on extrusion or by cutting and stamping. Okay. Then we now have the drying and curing, which has to do with evaporation of excess water and aging. Aging here means allowing the soap to harden and mature, right? Then we have the packaging and finishing, which has to do with wrapping and labeling, and then probably the quality control and inspection, right? So, but this is just a typical unit process involved in the manufacture of soap. Another example we could consider is the manufacture of ammonia by the Haber process. So, and it actually entails the unit processes, being the first one is nitrogen fixation, that has to do with separating nitrogen from air via liquefaction. Then we now have hydrogen production, which has to do with steam reforming of natural gas or other hydrocarbon. And then the same process, we have the gasification of coal or other carbonaceous material that could actually produce hydrogen. Then we now have the gas processing. The gases are to be processed by removing impurities such as hydrogen sulfide, carbon dioxide from the gas streams, and then adjusting the ratio of the nitrogen to typically 1:3, and then this is followed by compression of the gases, which has to do with raising the pressure of the gas mixture typically to 200 to 400 atmospheres. Then we now have heating. Heating has to do with raising the temperature of the gas mixture typically to 400 to 450 degrees Celsius. And then we now have the reaction, of course, which takes place in the reactor, which has to do with passing the gas mixture over a catalyst, usually iron-based, to form ammonia. This is followed by cooling. Cooling is done by lowering the temperature of the gas mixture to condense the ammonia to liquefy it. And then the process is followed by separation, which has to do with separating the ammonia from the unreacted gases. And then as it is recycled, and then purification is taking place again, which is removing any remaining impurities from the ammonia product. Then we now have the final stage, such as the storage and handling. That has to do with storing and handling the ammonia product, liquid or gas. Okay.